Thank you very much. Okay, so I think in the interest of time, we'll get started. I would like to say good morning, good afternoon, or good evening to you all, depending where in the world you are joining us from today. Thank you very much for being here, and welcome to one of our online information sessions, which we're hoping to take a deeper dive into the data director. This was actually ranked the second priority tool during our recent global RDA's community consultation on agentic AI in research. So this is very much a preliminary first pass information session just to have a look at what the data director might be able to do, some features and functionalities that might be of interest to the RDA community, and have a look overall at this particular agentic AI tool. This is actually part of the RDA's Global Agentic AI initiative that we started running at the end of last year. We had an online survey and a series of information sessions, as well as two that we had on agentic AI more generally last week. We actually had an information session on the data director earlier on today, at 5 a.m. my time this morning. And then obviously we have this repeat session today to accommodate as many time zones as possible. These information sessions are open to anybody interested to be able to attend. We also have two more on Thursday, which are looking at the funding finder. For those who don't know me, hello, my name is Connie Clare, and I'm the Community Development Manager at the RDA Global. I will be sharing these slides after the event via email, but Irina Hope, who is the Global Events Manager at the RDA, is also with me on this call. She'll share my email address in the chat. And thank you very much, Irina, for being here. Irina's helping with the Zoom logistics and sharing information for you in the chat today. So thank you. So just a bit of housekeeping before we begin, just to let you know that this session is being recorded, and the presentation and the recorded video will be published online. Please do mute yourselves just to minimize any background noise. If you're willing to have your camera on during the discussion, you're more than welcome to do that. We do like to see your face, but of course, if it's recorded and you don't want to do that, that's also fine. This is an RDA organised event, so we will be adhering to the RDA's Code of Conduct. So please can I ask you just to listen openly and respect all the perspectives shared today. We have around 25 minutes or so of presentation, and then we'll open the floor for a discussion with you, and you can ask any questions. If I can answer them, I will do, but of course I'll also keep them on record, and if they are technical and I need to get back to you, I can also do that as well. If you have any questions or comments about the RDA's work on artificial intelligence or agentic AI specifically, you're also welcome to contact our Secretary General, Hilary Hanaho, and again, Irina will put Hilary's email address in the chat for you. So today's agenda, I'm going to take you through some of the background context, and I do apologise if you've attended some of these information sessions before. It will be a bit of recap and a repeat of some of the information you might already have heard. So I'll give you background on our consultation that we ran at the end of last year, and then a bit about the features and functionalities that have been proposed already, about the data director and some of the community's perspectives of that tool. And then we can talk briefly about the blueprint and what makes it an open technology agnostic blueprint. And our collaborators as well, Microsoft, have also provided an AI assisted recording, AI generated recording that I'll play for you, so you can get some insights there, and then we'll have our Q&A and closing remarks and next steps before we finish. So for those who might not know much about the RDA or are new to the RDA, welcome. The RDA was established in 2013, and it's an international member-based organisation that has grown to comprise more than 16,500 members spanning 150 different countries, so we are very global. And we share this common vision, mission, and our guiding principles that researchers and innovators openly share and reuse data across boundaries, across technologies, disciplines, and countries to address the grand challenges of society. And the community comes together to build the social and technical bridges that enable open sharing and reuse of data. And importantly, at the heart of everything we do within the RDA are our 6 guiding principles of openness, consensus, inclusivity, harmonization. We are community driven, and non-profit and technology neutral. And that means that all the work that is produced by the RDA community is openly available for adoption and reuse by anyone, anywhere in the world. And if you're not yet a member of the RDA, you can join for free, and we are open and welcoming to anybody who subscribes to our vision, mission, and guiding principles. So the work that we started to undertake more formally within the Secretariat on Artificial Intelligence was around 2 years ago now. So we do have a dedicated web page, which Arena will share, that actually outlines all of our past projects, activities, and initiatives. And from there, you'll be able to see slides, recordings, any reports or white papers that have been generated by the community from past events and also our future events. We also have a section on the web page for our community experts to give them some more visibility and to highlight what they've been achieving. So these are individuals who have contributed to some of these initiatives in the past. You'll also be able to read more about future work and how to get involved there, as well as any RDA groups that might be of interest for you to join that are related to the topic. So the work that we actually undertook on agentic AI in support of science and research was in November 2025, and this was in collaboration with our organizational member, Microsoft, as we have a mutual interest in this particular topic. We appreciate that agentic AI or AI agents are becoming more commonplace, and it's somewhat of a buzzword among the community. There's an idea, of course, that AI agents can autonomously assist with various tasks throughout the research lifecycle, from data analysis through to data publication, research evaluation, and impact. There is the promise that it could accelerate research, reduce costs, and also provide access to tools that might not otherwise be available. So what we wanted to do was open an online survey and run several information sessions to find out how the research community is currently using agentic AI, if they are using it, what are the needs and challenges that might exist, or where could, or probably importantly, how could agentic AI have the greatest impact throughout the research lifecycle? And all of the perspectives from the community were drafted in an open report, which I'll share on the next slide. And we're hoping for the next quarter, from April to June, to start collaborating with the RDA community on the development of an open technology agnostic blueprint for one of those priority AI agents. So Irina will share the link to the report if you haven't already seen it. And this report actually outlines or evaluates 11 conceptual agentic AI tools and shares the information on a global community priority or priorities for agentic AI in research. So if you're interested, you can also have a look at that. So I'm coming back to this question, and we discussed it in some depth last week during the RDA's virtual plenary. What is agentic AI? And there is some definitional instability. There is no one single definition for what agentic AI really means. And I'm sure some of you experts in the audience have different perceptions or notions or definitions yourself. Please feel free to share those in the chat. For the purpose of the consultation and the development of the blueprint, we've settled on the definition that agentic AI refers to artificial intelligence systems that possess autonomy, goal-directed reasoning, and the ability to act independently with minimal human oversight. So this idea that there can be a series of tasks within a pipeline and there is minimal human intervention. And this is in contrast to traditional AI models that typically respond directly to prompts, so some of the LLMs like ChatGPTs and Claudes that we might be more familiar with. So what did we do in the consultation? As I mentioned, we had online information sessions where we had international guest speakers. We had this 15-minute anonymous survey open for 1 month where we received 83 responses from 25 countries. The largest group of respondents were researchers and scientists. And the vast majority, around 90%, had used artificial intelligence or machine learning tools previously, and around half had not heard of agentic AI or used agentic AI systems. And for the purpose of the survey, what we did was we proposed 11 agentic AI tools that could help with different tasks throughout the research lifecycle. And these tools were actually identified as potentially useful from a previous engagement that Microsoft had run with around 50 universities within the UK. And we asked respondents to score these tools. So we provided a description of their features and functionalities, and we asked them to score them based on their usefulness. So whether they were very useful to not useful at all or unsure. And you can see on the right-hand side, this is the weighted scoring and the ranking. So you can see the top 3 priority tools were the literature librarian, followed by the data director, and then the funding finder. And the least priority at the bottom, you can see our collaboration catalyst, publication preparer, and an ethics reviewer. And you might have your own ideas for how you'd rank them or why they might be ranked in such an order. So this is a bit of a busy slide, and it's also in the report, so you can have another look at it if you wish to. But this shows the research lifecycle in the centre, from formulating new research questions and hypotheses through to reporting on research output and impact. And the priority tool, the literature librarian, could possibly help with natural language literature searching. It could be integrated with library subscriptions or contracts to access articles, open access and behind paywalls. The data director, which is obviously the tool we're looking at today, in second place, could possibly help with automatic metadata creation to ensure compliance with the FAIR and FAIR squared principles, which are specifically for AI, could help with assigning DOIs, a workflow for assigning DOIs for data sets, and provide guidance on where data could be archived or published to be compliant. And then in third place was the funding finder, which could scan scattered and niche databases to match calls with ideas, provide templates for applications, and also suggest improvements to applications based on previous successful applications from institutions. So now I'm going to focus more deeply on the data director. And just a reminder from the previous slide, we described 3 functionalities to the community. So we thought, or it was proposed, that the data director could help again with creating metadata in accordance with the FAIR principles, minting DOIs for data sets, or recommending appropriate data repositories to ensure compliance with funder and institutional requirements. And as you can see from this donut chart here, that just over 70% of respondents thought this tool would be useful in some way, either very useful or somewhat useful. Around 17% didn't deem the tool useful, and around 10% were unsure about it. So I'm now just going to talk briefly about the needs and features and what the community thought about this tool and how it could help. So there was a vast majority that responded with the fact that automatic metadata creation to ensure FAIR compliance would certainly be of use to the community, and that it would allow researchers to spend more time on research tasks. The creation of metadata is, of course, valuable, but researchers sometimes don't find the time to be able to do it or know how to do it effectively, and that this automatic creation could possibly reduce human error and administrative workload for researchers. There was also comments to suggest that this tool might be more valuable for smaller organizations that don't have the research support staff or the resources to be able to support data publication processes. There was a thought that if we could somehow develop a blueprint for a tool like this that could standardize data or suggest formats or verify manuscripts for fairness, that would be useful, and recommend appropriate or compliant data repositories. And then there was a respondent that also suggested that creating automated file packages, the generation of and upload to repositories, including data software and metadata, with quality assurance mechanisms for data, would also be something that could be very useful for the community. And of course, the needs and features were also balanced with some challenges and complexities that I'm sure some of you here will understand and resonate with. The idea that, of course, AI-generated metadata is not always correct, that AI can hallucinate, and so there was a concern about the accuracy and reliability of this metadata, and that it would require a human in the loop and checkpoints to fact check those AI suggestions, and that this would require some technological comprehension by users. There were some transparency concerns because, of course, with agentic AI, the more you automate a process, the more of a black box it can appear, and that it could actually misrepresent data in the metadata. There was also a question about who funds the DOIs. That of course this costs money, and there are repositories that already provide DOIs for data sets. So that's a consideration that we need to take into account. That data repository identification is already an existing service. There was also this added complexity that institutions and organizations have their own policies for preferred repositories, institutional repositories, and that this would not match with AI suggestions or recommendations. And this would, of course, cause some conflict among researchers. And there was the challenge of maintaining control over metadata. So who is responsible for creating the metadata and ensuring it's correct? Who's liable and who checks if it's correct? And also this idea that to improve the AI capabilities, there would need to be some harvesting of training data to create more accurate metadata. So these were all very valid concerns and complexities that we can, of course, have a discussion about during the session today. So for the final few minutes, I would just like to move on to the concept of the blueprint. So what is an open technology agnostic blueprint? So from our perspective within the RDA at a very high level, the open is to allow the community to get involved in its development and that it's transparent and that the product, the blueprint at the end is technology agnostic, it's freely accessible and implementable by different adopters, and that it's obviously community governed in accordance with the RDA's guiding principles. That's very important to us. The technology agnostic aspect is this is about the functionality and the specification. So what does the tool do and how does it behave without prescribing a particular technology, such as an AI model, cloud provider, or infrastructure? And the blueprint itself is that it's a community developed specification or framework that anyone can implement, whether that be a university or a national research infrastructure or a commercial vendor. And of course, it should have a clear definition of the problem and the problem being solved and who the user community will be. We also outline here some considerations which really reflect back to some of those challenges and complexities. So we need to consider how do we align with fair and fair squared principles, which of course are aspirational. So how is compliance measured and validated? In terms of accuracy and trust, as I mentioned, that AI generated metadata is not always accurate, and there is some concern about that. So what kind of quality control and human in the loop checkpoints are needed to make sure that we can validate this? Considerations also about institutional and regional diversity in terms of policies on data management and data governance, repository use, and who funds the DOIs or how that is managed. Transparency and explainability, making sure that users can understand and challenge AI suggestions. In terms of interoperability, this tool would need to be able to integrate with existing research infrastructure, whether that be repository APIs or institutional portals. Ethics and privacy, of course, in terms of how we manage and handle sensitive data sets and use this tool to create metadata for that. And then, of course, sustainability in terms of financial, technical, and community sustainability to ensure that the tool is viable, sustainable, maintained, and implementable in the long term. So before I share the video that has been generated by our collaborators, Microsoft, I also just want to share some of the components of a blueprint. Some of you may have developed blueprints before and have your own ideas. So functional specification, we need a clear definition of each core capability, whether that be metadata creation, DOI minting, repository generation, recommendation, or file package generation. In terms of input and output standards, understanding what kind of metadata schemas this particular tool will use, whether it be DataCite or Dublin Core, and what is generally accepted among the community. Again, I've mentioned this a few times, but making sure that we can evaluate and check the compliance with the FAIR principles. It should also include some kind of reference architecture. So this would be a high-level technology map or diagram that can show the data flow between the components. Also a governance model for the sustainability, so how it be maintained and updated. Implementation guidance, so practical notes for adopters, and specifically if it's for those smaller under-resourced institutions as the main beneficiary. And then also the risks, the limitations, and any open questions that we have, such as the DOI funding and how we reconcile between institutional policies and AI suggested repositories. So we do have two software engineers that are going to collaborate with us from Microsoft over the next few months. So I'm very grateful to George Earle and Benjamin Wright-Jones, who are happy to help with the development of this technology agnostic blueprint, and they're very aware about that remit for the Research Data Alliance. And Ben has also created this video, which I'm going to share on the next slide. You might need to turn your volume up for this.
When building an architectural blueprint for a cloud solution, it is crucial to keep the business outcomes and end-user experience front and center. However, there are times when not all business outcomes are always known, and there are times when horizontal platform capabilities are required before proceeding to use case considerations. Architecture blueprints should provide a clear, scalable, and secure design that meets both business and technical requirements without being tied to any specific vendor. The process typically starts with understanding the business context. This means identifying the problems we are trying to solve, the users involved, and the expected outcomes. At this stage, we discuss functional requirements, what the system needs to do, and non-functional requirements, such as performance, scalability, security, and availability. Next, we move into defining the high-level architecture. Here, we break the system into core components. For example, we might identify layers such as presentation, application logic, data, AI, and integration. The key is to think in terms of capabilities rather than specific services. For instance, compute, storage, networking, and identity management, instead of naming particular products. Once the high-level view is clear, we can focus on designing the core components in more detail. This includes deciding how services communicate, whether through APIs, messaging, or event-driven patterns. We also define how data flows through the system, where it is stored, and how it is accessed. And it is important to understand geographic and regional policies can inform data usage, retention, and security. Security should be embedded into every layer of the architecture, not treated as an afterthought. The next step is designing for scalability and resilience. We ensure the system can handle varying levels of demand by using techniques such as elastic scalability, horizontal scaling, load balancing, and fault isolation. We also plan for failure, designing components so that if one part fails, the system can continue to operate or recover quickly across geographic boundaries if needed. We then consider operational aspects such as site engineering, reliability, and observability. A good cloud architecture includes visibility into system health and performance, enabling teams to detect and resolve issues quickly. Automation is also key here, using infrastructure as code and automated deployment pipelines to ensure consistency and repeatability. Another important step is cost and efficiency planning. Even in a vendor-agnostic design, we think about how resources are consumed and how to optimize usage. This might include designing for elasticity, choosing appropriate storage tiers, or minimizing unnecessary data transfer. Finally, we bring everything together into a visual blueprint and documentation. This typically includes different viewpoints, data flow diagrams, and written explanations of design decisions. The blueprint should be clear enough that different stakeholders, from engineers to business leaders, can understand how the system works and why it was designed that way. Building a cloud architecture blueprint is an iterative and interactive process. It starts with understanding requirements, moves through structured design and validation, and results in a flexible, secure, and scalable solution that can be implemented across different cloud providers. The key is to focus on principles and patterns rather than specific technologies, ensuring the architecture remains durable and adaptable.
Okay, so thank you for your attention.